Hi, everyone. We're just going to give it one more minute and then we'll get started. All right, everyone. Welcome back. I hope you enjoyed your the kickoff of the breakout sessions. I know that I did. So I just wanted to very briefly introduce myself. My name is Tasman Powers. I'm the Deputy Manager for the Fusion Forum this year. A couple of very brief housekeeping notes. So as Kristen said at the very start, we're going to be doing a raising of hands if you have questions following the keynote presentation. Those do appear to occur in order along the side here. So then I will call on each of you if you have a question, and hopefully that's the order in which you asked it. If you also have a particular question you want to put in the chat, at some point I'll get to those as well, provided we have time. Also, just another quick reminder. So the rest of the day here with Peter and then with our NASA Scan keynote is going to be here on Zoom. And following that, we'll be moving to the GatherTown networking platform. We will let you know when we make that transition, and we'll put those links again here in the Zoom chat. So now it's my great pleasure to present our keynote speaker for the day, Peter Beck. Peter founded Rocket Lab in 2006 with the goal of opening access to space. Under Peter's leadership, Rocket Lab has become the leading end-to-end space company delivering advanced rockets, satellites, and spacecraft. In terms of engineering achievements, Peter led the development of the Electron rocket, a launch vehicle comprised of the world's first carbon composite structure, as well as the Rutherford engine, the first 3D printed electric pump cycle orbital rocket engine. Through Rocket Lab, Peter has helped New Zealand to take enormous strides as a spacefaring nation, from the development of the New Zealand Space Agency, the first private orbital launch site, and now with opportunities to be involved in the future exploration of the Moon and Mars. Rocket Lab has been a catalyst for good in Peter's home country, as well as for the rest of the spacefaring world. Peter's been decorated with numerous awards, too many to mention. However, I will highlight his medals from the Royal Aeronautical Society for services of an exceptional nature and innovation breakthroughs. He's also been awarded New Zealander of the Year and Regional Entrepreneur of the Year. I would also like to present him with the unofficial SGAC Best Hat Eating on YouTube Award. Finally, and on a personal note, as someone who originated from a neighboring nation in the Southern Hemisphere's oceans, I can say that Peter is an inspiration for many who hail from countries without established space economies. And he is certainly evidence that each of us have the potential to make a difference with our own nations and from around the world. So thanks, Peter, for joining us on an early Sunday morning, and we are looking forward to hearing from you.
Oh, thanks very much, Tesla. That was a very generous introduction for sure, probably too much so. And I can confirm that, in fact, when you grind up a hat in a blender, you just release all of the toxic chemicals that go into making a hat. And when you pull the top off, it's like some kind of crazy explosion of chemicals. So what I want to try and do here is not make this like a company pitch, but rather give you a little bit of background of the company if you're not familiar with it, and spend spend a bit of time on questions if that's okay. So for me personally, the youngest memory I actually have as a child was standing outside with my father in a cold Invercargill night. Invercargill was a town at the bottom of the South Island in New Zealand, and looking at the stars. And I remember him very clearly saying to me that those stars were in fact suns like our sun, and they most likely have planets orbiting around them. And there could in fact be somebody just like you standing on one of those planets looking back and asking, the kind of the same questions and looking at us. And for, I don't know, maybe a 3-year-old, 4-year-old, that was kind of a mind-blowing thing that got etched into my memory. And from that point onwards, that was me destined to work in the space industry. And the plan for me originally was, to go and work for one of the more traditional companies, like or organisations like NASA or one of the big space primes, and kind of set myself up, as an engineering career to go and do that. But in New Zealand, there is no, there was no, university education that kind of laid out a clear path to go and working in the space industry. So when I left school, I didn't go to university. Actually, I went and did a trade in tool and die making. And the reason why I went into to do a trade was I couldn't learn about rocket engines, but I sure as could heck build them. So I needed the hand skills to be able to continue to be able to build rocket engines. So I went into trade and started building rocket engines. And in my entire life, I've always kind of run 2 shifts. So the day shift was where I had to do a real job for a while, and then the night shift was always building rockets. And I was very, very fortunate through my career that the companies I worked with and worked for, and the government organisations that I'd worked for, always encouraged or tolerated, maybe is a better word, me using some of their facilities and doing things in their facilities at night. So, when I joined. I did my apprenticeship at a company called Fisher and Paykel, and they made whiteware products, and tremendous exposure to manufacturing. In fact, I ended up as a manufacturing engineer there after my apprenticeship. But that's where I started really having the ability to leverage those facilities and start building rocket packs and rocket bikes and all kinds of things. And then when I went to work for the New Zealand government in what's kind of equivalent of a national research lab, then I was, that was really fantastic, because I was able to leverage all the Crown asset and started building really, much more significant engines and propulsion systems. And it wasn't until it was 2006 that I jumped on a plane and I went to the US, and it was kind of like a rocket pilgrimage. Like I spent a month over there visiting all the places that I'd corresponded with over the years, visiting all the NASA facilities that I'd watched on NASA TV. And out of that trip really came 2 things. It was a bit depressing, actually. I mean, what actually came out of that trip was all the things that I thought were fundamentally important to be happening weren't happening. But what was quite encouraging out of that trip is when I visited all the little shops in the Mojave Desert, doing these little programs, actually they were no different in level to what I was doing at home in my garage. So I got on the plane on the way home and kind of realized, well, I'm not a million miles away from what everybody else is doing at a small scale. And fundamentally, what I think should be happening is not happening. And that was a small dedicated launch vehicle for small satellites. So on the way home, there's nothing like 12 hours to kind of, reconsider your life. And by the time I'd landed, I'd doodled a Rocket Lab logo, arrived to work the next day, quit my job, and that was the start of Rocket Lab. And from sort of 2006 to 2009, we sort of cut ourselves out as a little advanced technology house. So we're doing little contracts for DARPA and little contracts for Lockheed and various people around the show. But it was all kind of subscale. But it was a really important time because it was about building credibility and capability. So it got to a point, it's like, right, we really need to build this Electron launch vehicle. And I think I've got enough credibility within the industry and capability now that I can go to Silicon Valley and try and raise capital. And you have to understand, like, as a Kiwi, jumping on a plane and going to Silicon Valley was a big move. In New Zealand, everybody warned me that you go to Silicon Valley, it's full of sharks, and you're going to get spit out, chopped up, spit up, and that would be a terrible experience. Actually, ironically, it turns out it's the other way around. Our local venture capital industry is far more like the sharks than Silicon Valley. So I arrived in Silicon Valley, and I gave myself 3 weeks to either be run out of town or come home with a check. And the first week, I visited a bunch of little companies to try and figure out how the Silicon Valley thing worked, that was really important. And I think one of the things that has been instrumental in Rocket Lab's success has been choosing the right investors. Actually, money's not that hard to find. Money with the right kind of minded investors with the right kind of contacts is actually far, far more important. I mean, the least valuable thing an investor gives you is their money. So in the end, I only pitched to 3 companies, or three VC firms. And in fact, I did come home with a check, and that was kind of really the beginning of Rocket Lab, and that was in 2014. And then from 2014 onwards, we really set to building building the Electron launch vehicle and really getting stuck in. So I'll share a bit of a presentation here. Like I say, I really don't want this to be like a company pitch, but you kind of get the general gist of it. So, just for those who aren't familiar with Rocket Lab, so at a glance, we've launched to space 21 times. We've got 105 satellites in orbit. We operate 3 launch pads in 2 countries. We're the second most frequently launched US rocket, just behind SpaceX. We have 2 mission control centers. We've done 8 missions now for the most discerning US government customers. We've made 1 strategic acquisition of Sinclair Interplanetary, which is, Doug and his team has been just the most incredible group of people to bring on amongst the organization. We've built a couple of factories. We've got 2 of our own satellites that we build and operate. We recovered 2 first stage orbital class boosters from space. We have 3 interplanetary missions scheduled, and we've got a relatively unique on-orbit propellant depot contract that we're working on as well. I think you can define the company by really being vertically integrated. And when I say vertically integrated, it's not like it's not like we kind of buy a few things here and there and like to integrate them under one roof. It's like literally raw material in one door, rocket out the other, or satellite or spacecraft out the other. Right down to our launch site. It's the only privately owned launch site in the world, and when we built that launch site, we had to there was a bilateral treaty that had to be created between the United States of America and New Zealand to enable us to launch. The New Zealand government had to put through the entirely new laws and legislations called the High Altitude and Space Activities Bill that had to go through Parliament Select Committee, ultimately into law. Once it was in law, somebody needed to actually administer that law, so the New Zealand Space Agency was created, and then we had to amend and change a whole lot of New Zealand laws. So a good example is we had to get space designated as a freight destination, because if you import anything into New Zealand, there's a tax called goods and service tax that gets applied, but not if it's a temporary import-export. So we were in a situation where our customers could bring in a satellite and get charged 15% tax just for the satellite to come to New Zealand to be launched. So a whole bunch of stuff like that. We had to upgrade the internet backhaul to entire townships. We built tracking stations all around the planet. We built 30 kilometers of new road, and on and on and on it goes. So literally, like I say, at Rocket Lab, it's raw material in one door and rocket and spacecraft out the other. We do all of our own propulsion systems, avionics, software, structures, right down to just pretty much gravel. I mean, and welding, so full end to end. The one thing that I would say about Rocket Lab is that everybody who joins the company gets measured from, did you do what you said you would do? And I think this industry is awesome. There's a tremendous amount of excitement and tremendous amount of ambition. But sometimes I find that there's a little bit too much hype and a little bit not enough execution. And we're all about execution. And if you look at, I guess, our history here, so we raised the first venture capital, as we said before, in 2014. By 2017, we had our first vehicle on the pad and launched. By 2018, we'd actually been to orbit 3 times. By 2019, we were the 4th most frequently launched rocket in the world. And then when we started our space systems group building satellites, we announced that in 2019. By 2020, we were awarded 1 mission to the moon, 2 missions to Mars, a private mission to Venus. We had our first Photon on orbit that we designed and built. So we weren't messing around on that either. And then I think the other thing that is kind of less obvious is our space applications. So what we're trying to build here as a company is, I've always believed that if you own your own rocket, you own your own satellite, then your ability to build and put infrastructure in orbit is unparalleled. So we're starting to build our own satellites to put in and put 2 of them already on orbit to test our own things for ultimately providing services from space. So I think a lot of people think that Rocket Lab is just a launch company, but actually we, like I say, we build satellites, spacecraft, and provide applications. We talked about this. We launched a bunch. The only thing I really want to point any attention to here is this little white thing on the top by the fairing there called the kick stage, because the kick stage is actually a really, really important aspect of the vehicle and quite frankly Rocket Lab's ethos. So I don't feel that you can stand on a stage and say, hey, look, we're going to launch really, really frequently without having a really good explanation about how you're going to do that sustainably. One of the things I worry about a lot, excuse me, is kind of, there is a massive race to space and who can build the smallest rocket, the biggest rocket, whatever. And there's really, there's not that much consideration as to how you do that sustainably. And it's kind of like the industry's dirty little secret. Like, everybody thinks the space junk in orbit is dead satellites. Well, actually, a lot of the space junk in orbit is actually dead rockets, upper stages and second stages and fairings and all sorts of kind of junk up there. And that doesn't get any press, but actually, by mass, it represents a large portion of all the space junk that's in orbit. So when we went into space, we said, well, if we're going to build a launch vehicle, let's not contribute to that. So that little thing at the top called the kick stage is actually fundamental to ensuring that. So when we go into orbit, our second stage, sort of that chunky bit below it, generally that doesn't stay in orbit for more than 2 to 4 weeks. We put it into a Hohmann transfer or highly elliptical orbit, and the Earth's atmosphere catches that and it burns back up in, like I say, at about 2 to 4 weeks. Then the kick stage carries on, and with the kick stage, you can kind of think of that like, it's like the original space tug. So we'll take the kick stage and then we'll deploy off our customer satellites. Sometimes we'll do plane changes, orbit raises, orbit lowering, in fact. And then once it's all said and done, that kick stage does one or two things. One, it transitions into a satellite for ourselves, or two, because it has a propulsion system on board, we fire that engine, consume all the propellant, and put it into the lowest orbit possible for the shortest deorbit time possible. So that's kind of important to us. Like I say, I worry a lot about how we manage our resource in orbit. We've been to the UN and participated there in trying to discuss and engineer solutions for that. Unfortunately, I think it's probably going to take an event before the world comes together to agree on this. The one thing that was incredibly inspiring about the UN on this particular matter was that everybody, even countries that don't like each other, got together to talk about it. However, the kind of slightly depressing thing is nobody has agreed on anything since, I think it was like 1972. So we've got our challenges here to try and come together as a species to look after that piece of environment, so that we can really ensure that it's not ruined for future generations. Another big program we have is on the Electron, is a reusability program. We do it a little bit different to SpaceX. So the concept here is to snatch the stages out of the sky with a helicopter as they're descending. And I know most of the time when you say that, people kind of look cross-eyed at you thinking that's a little bit crazy. By far, that piece is the easy piece to do. actually re-entering a stage, an orbital class first stage is really, really hard, actually making it survive the re-entry. So but a very successful program here. We've re-entered 4 stages. We've recovered 2 under parachute that have splashed down out of the ocean. This year we've got another 2 recovery missions to fly, and all going well, we'll try and snag one with the helicopter this year. Now it's like 400 kilometers off the coast of New Zealand, so it's way out in the middle of nowhere. So that it is very challenging from that perspective. But I think reusability is fundamentally what's required in future launch vehicles, and this is one of the many reasons why I had to, in fact, consume a hat. So before I guess, well, we'll talk a little bit about Neutron. The Electron launch vehicle is a really, really useful vehicle. It's a fantastic product that fills a market space where we need small dedicated launches for small dedicated spacecraft. However, as we kind of look at the market more generally, it became obvious that a large launch vehicle was required. So we've introduced a new product line called Neutron. Neutron's pretty cool in the fact that between Neutron and Electron, you suck up about over 90% of everything that needs to be launched in the next decade. And it's an 8-ton class launch vehicle. And you might, I think a lot of people ask me, well, why did you settle on 8 tons? A Falcon 9 can lift more than that. Why wouldn't you go for more than that? Well, actually, we let the data make the decision here. So if you look historically at, the average launch mass of all launch vehicles in history has been 5 tons. If you think about human spaceflight, you don't need any more than 8 tons launch capacity for that. So sucking up that extra few percent of the 90% of the market in order to be able to lift the really heavy stuff really doesn't make sense from an operational perspective. So we think we have right-sized for the vast majority of all launch in the market, and that just enables us to be incredibly cost competitive, because we don't need to carry dead structure and dead propellant. I will say that the image you see of Neutron there is a bit of a ruse. Neutron looks nothing like that. Basically, we're sick of people copying us all the time. So we put that image there as a bit of a, well, at least internally it's a joke. I think externally people are probably busily copying it right now. But that's not actually what Neutron looks like, and there's going to be an announcement here in time where we'll actually show what we've really built. So that's kind of our rocket part of the business, and then our a big part of our business is also spacecraft. So not just building kind of boring stuff. The spacecraft division is kind of broken up into a couple of areas. One is low Earth orbit, and the other is interplanetary. I won't spend too much time talking about the low Earth orbit stuff. I think that's pretty well known. I'm very passionate about exploring other planets in our solar system. I think there's a tremendous amount to learn here. We have 3 kind of the trifecta of near Earth objects. So we have a capstone moon mission that's launching later this year. In fact, we've just announced that that's going to be launching out of New Zealand. So that's pretty cool to for one of the very first Artemis missions actually being launched out of New Zealand. It's pretty cool. We have the Venus mission, which is actually Rocket Lab's own private mission, together with various science teams around the world. This is to fundamentally it's a life-finding mission, and the Venus mission really is kind of the full circle of the my childhood memory, standing outside and talking to my father about other people looking back at me. And I always promised myself that if I ever had the opportunity to, at least try and ask life's, well, at least humanity's largest question in my mind is, are we the only life in the universe? Then I would take it at all cost. And really, I think if you want to be scientific about it, in the absence of evidence, currently you'd have to say we are the only known life in the universe. Statistically speaking, there probably is life elsewhere, but until we kind of prove it, then that's what all the textbooks are going to have to say. So this mission is a very high risk mission. We are descending through the clouds of Venus in that sweet zone of about 50 kilometers with 1 to 2 instruments, with the express purpose of determining whether there is life there or not. The answer will come back yes, or the answer will come back no. Very high probability if we actually get there, then the answer will come back no. But if the answer comes back yes, then the world's just changed. So this is a mission that Rocket Lab is funding, both the launch and the spacecraft element, and we have a lot of mission partners for the instruments and the science against it. We also have 2 missions to Mars, so 2 Photon spacecraft. We won't launch those spacecraft, but NASA will launch those spacecraft. But those are to measure the environment and atmosphere around Mars. So super cool stuff. I think interplanetary work has the greatest ability for the minimum amount of effort for huge payoffs. Especially when you look at our capstone mission, it's like a $10 million mission, and we're going to the moon. The Venus and Mars missions, of course, equally as affordable. I wouldn't be doing my job if I didn't put a plug in to come and work for Rocket Lab. It is an incredible environment. I think the average age of Rocket Labber is something like 30 years old or even younger. Incredibly, dynamic team, and it is really the UN of the rocket industry. Down in New Zealand, we have just about every nation you can imagine represented. We have headquarters in Long Beach in California. We have offices in Canada as well. So one of the biggest throttles for Rocket Lab is talent. So like I say, I wouldn't be doing my job if I didn't take the opportunity to do a sneaky plug here. And please think about coming and joining the team and doing some fun stuff. So with that, like I said, I didn't want this to be a sales pitch. So love to take any questions that anybody's got.
Thank you, Peter, very much for spending the time to talk to us. My head is teeming with questions, but I won't use that privilege to jump in. There's already, I see quite a few hands raised here. So if each of you would just unmute yourself when you got that question and ask it, and then Peter can come back. So the first person I've got here is Grace Graham.
All right, cool. Hi, I'm Grace. So my question is, being from the US, I feel like a lot of my knowledge about what happens in the politics of space and in the space industry as a whole is biased around the United States actions. So how do you feel that the creation of Rocket Lab has affected the perception of space, both civil and political, in New Zealand and around the world? And how has it changed the way that countries are working together to build new policies and technologies?
Yeah, that's a great question. So, we are a US company. The New Zealand is a subsidiary of our US enterprise. But I would say that certainly from a policy perspective, there was a bilateral treaty that had to be signed between the US and New Zealand, and that was incredibly well supported by both countries. I think it's interesting when New Zealand had no space industry, and then now it's busy as anything, and there's a lot of education that's required. We've done 150 schools. We've got another 50 schools to go. It's fascinating coming into an environment where people know very, very little about space. In the US, I think every child has grown up with the ability to go to Cape Canaveral or the Apollo program and the space shuttle program is taught and etched into everybody's minds. A little country like New Zealand, it's not it's not at the forefront. So we spend a lot of time in education. I think from a policy perspective, like I say, the bilateral treaty certainly between allies is very, very very transformative in a lot of ways. So the same policy that was used between New Zealand and the US that we kind of established is now the same policy that's used between US and America. Brazil also has a TSA agreement, and the UK is just working on their TSA agreement. I think it was just recently signed. So that one TSA agreement was originally between, US and New Zealand, because of Rocket Lab is now, at least we know, 4 other countries are using that, and the collaboration between those countries and space has continued to grow.
That's really awesome. Thank you.
Thanks, Grace. And we got Mina Takla up next.
Hi, Peter. Thanks a lot for sharing your story, and thanks a lot for taking the time to be here. So that's been a truly inspirational story, and I would like to ask that from your own experience, someone who's leading a little moonshot company, what would your advice be for founders that are starting out in the space industry in terms of setting a bold vision for the future and executing on that? Thank you.
Sure. Thanks very much, Mina. I mean, look, I think nobody goes into the space industry, especially as an entrepreneur, thinking it's going to be easy. Like this is the hardest thing you can go and do. Let's be honest about it. So if you're going to devote, such energy and effort into something that's hard, then don't pick a small problem. Don't mess around with trying to solve a little thing. It's going to chew your life up, and you're going to have to absorb every waking second into it. So go after doing something that's really, really massive and transformative. Really, that'll be my only advice is like I say, don't mess around with the small stuff. Go big, and see how far you can push it.
I don't know if you get that same advice from everyone, but I really love that. Sorry, Mina, didn't mean to cut you off.
Yeah, thank you, Peter. Love it.
Thanks, Mina. Next up, Sean Mitra.
Hi, Peter. Another entrepreneur here that loves the story and everything that you've said. My question is more coming back to that treaty between New Zealand and America. I don't know how much you can even divulge, but as someone, based in Canada, and our company is looking to set up a company mining water on the moon. And one of the early hurdles we've really run into is really engaging the Canadian government and trying to get them sort of caught up to speed with some of the other jurisdictions around the world in terms of legislation, policy, and support. So I guess maybe more generally, my question is, how do you build those networks? Like, do you have any advice? I mean, I'm trying my best through this and everything else I can to pester everyone, but.
Yeah, so it took me a while to learn this, but like engineering is awesome because it obeys the laws of physics. It's very logical and linear and non-linear at the same time. It's very, very logical. Governments do not obey any laws of physics. A completely non-linear problem. What you have to work out is governments only do things that are in the government's best interest, and you need to make politicians look good. As long as you follow those kind of two things, then you can actually start to move forward. And also, sometimes no is just the wrong answer. No is often yes on a different day. So persistence is very important, and really explaining very clearly the opportunities that will present themselves and the opportunities that are lost with kind of the no. So finding that right person who's kind of prepared to champion it, and then look, it's at the end of the day, it's just about pushing and pushing and pushing. I mean, I went up to Washington DC, took a hotel room across the road from the State Department, and just didn't go home. I just kept turning up the State Department, the New Zealand Embassy for months, just didn't go home. So, sometimes you've just got to persist.
I think that's the second time today I've heard a comment regarding government not obeying the laws of physics and the challenges of that. Thanks, Sean, very much. Next, we have Julio Hernandez.
Thank you, Mr. Beck, for sharing your experiences and spending your time here to talk to us on this platform. I had one very general question and then one specific question that's related. And the general question is, what is Rocket Lab's policy on technology proliferation to to engineering solutions to the challenges that you face getting your platform up into space?
Well, I mean, so look, at Rocket Lab, the best design wins. So, at the end of the day, there's always tremendous number of engineering solutions. We favor kind of simplicity wherever possible, and then add complexity in after simplicity fails. And also we have kind of a policy of fail fast at small scale. So I think that's probably where Rocket Lab differs from perhaps some others, is that if we get to full scale and it's a bad day, then we kind of think that we've done that wrong. So our approach is to fail fast at the small scale, at the fundamentals, but by the time we move into full scale or large scale subsystems, we don't expect them to fail. So it's kind of in the middle between just kind of building stuff flat out and it failing a lot, versus kind of, I would say, more the traditional primes approach, where you analyze everything to the nth degree and it takes forever. We kind of sit in the middle there. We analyze and we test at small scale, but like I say, by the time it gets to large scale, we really hope and expect that we've solved those issues. So yeah, I mean, as a company, we're an engineering company at the end of it. Like the amount of non-engineers at Rocket Lab is very small. Even folks on the finance team are engineers. So tremendous engineering base of a company. And I think if you look historically over in a large number of really successful engineering companies, I think that's that's pretty key. So I'm not sure if that answered your question or not, but that's kind of how we run.
You touched on it very well, but I was trying to get at it from the angle of if you come up with a engineering solution for your platform, do you share that technology with the rest of the industry or partners, or do you keep it proprietary?
Well, I mean, I guess we in some areas we do share that we think are for the benefit of everybody. And then other areas we don't really need to share because people just copy us all the time. So it's kind of like sharing. I mean, we don't patent stuff. So Rocket Lab has like maybe 5-10 patents or something like that. We prefer to just move quickly. A good example is where we really share with the industry is like autonomous flight termination systems. So there's quite a few rockets today sitting on launch pads waiting for an AFTS system to be certified. And this autonomous flight termination system, it's been a program that Rocket Lab has had since Flight 2. We're certified by the FAA to fly it out of New Zealand and any FAA launch site. But the reason why we haven't launched from LC2 is because we're trying to get that flight termination system certified for NASA on any NASA range, in fact, any range in the United States. And then we'll make that flight termination system available for everybody to use. So, if you want to talk about taking one for the team, I mean, we've had a rocket sitting there for over a year while all of that software and certification is being done by NASA. So it's available for everybody in the industry. But that's one of those things where, safety is good for everybody. So we're definitely doing our bit on that one.
Okay, thank you so much, Mr. Beck.
Thank you, Julio. We got McLeod coming up next.
Thanks, Taz. Thanks, Mr. Beck, for sharing your story. It's actually really impressive how you said in the beginning you didn't go to university. I don't know if anyone glossed over that. But this has been going off Sean and Grace's question. How long did it take for New Zealand to start developing laws based off what you were doing? Like, how long was that whole process?
Yeah, so I went and sat with the government and told them what I was about to do, because you don't want to go and put yourself in the corner there too much. And we were very lucky at the time that at least some of the government was very supportive of that, and I think credibility is a big deal. So we'd raised a pretty significant amount of capital from tier 1 venture capital firms. So clearly we had good resources and good names behind us. But look, I remember sitting down with the CEO of New Zealand's science and research funding organisation. So this is an organisation that decides what to fund in terms of research in New Zealand. And I sat down with this guy, and he looked across the desk and he said, "You know what, Pete? The problem you're going to have is that New Zealand will never do space." So you run up against those kind of people, and he was just wrong, and that's fine. I told him he was wrong. He didn't appreciate that, and but look who's wrong now. And so you're always going to have those kind of barriers that get put up, but it's your job to just either navigate them or push them over, really. So yeah, I mean, it's really just getting on with it and finding those nuggets of fantastic people who really want to support it, and then just pouring fuel on the fire.
Thanks.
I've heard similar tales from other countries located in similar locations, so it's always interesting to hear that. We got Jessica coming up next.
I'm super impressed at the Australian. I'm super impressed at the Australian Space Agency, to be honest with you, Tasman. I mean, I think they're doing a fantastic job. They're actually they're funding the right things. They have an ambition, they have a vision. So I think they're doing an incredible job.
Yeah, I'm so thrilled to see how it's going these days. It's fantastic. Jessica, you're up next.
Yes. So my question has to do with what you were raising, Pete, earlier about the issues of sustainability. You're discussing about how you're reducing debris with your rocket stages, trying to do more reusability. And so I was just wondering, based on your experience, what do you think is needed to inspire these sorts of priorities to become more standard industry-wide? It can be rather slow in the whole international regulation type aspect. Like, do you see that there's a way for like a more of a grassroots industry-led initiatives to make it more sustainable long-term versus that quick get there and they don't look at the consequences? So thank you.
Yeah. So that's a great question. I think we're pushing it on from both fronts. So I think, look, absolutely there has to be some regulation. But it needs to be, we have to acknowledge that we all want the stuff that space gives us, right? But we also have to acknowledge that in order to do that, we actually have to create some rules and regulations to actually ensure that doesn't get abused. And then on the other side of it, we've just tried to do the best we can. And will a customer buy a launch service from Rocket Lab because it's clean versus a launch from somebody else? Probably not. I mean, nobody's probably going to get that kind of wound up yet. But I mean, there is a certain degree of knowing that what you're doing is best practice, and I think in time investors will look across and look for ultimately look for answers from others about, well, what are you doing? Why aren't you being sustainable in the sector? So I think in time, you may see a little bit more commercial pressure come on, but right now it's just a race to orbit, and I think if you go and talk to any of the launch companies and ask them what their sustainability program looks like, they'll go, well, we've got a solar panel on the roof here somewhere, yeah.
Thank you, Jessica, for the question. We have time for one, possibly two more. So let's start off with Stefano.
Awesome. Thank you. And thank you, Mr. Beck, for being here. So I was just wondering what the greatest challenge that you've experienced in kind of building Rocket Labs, especially in the beginning, and trying to vertically integrate as such a small company in such a new kind of sector. I was just wondering what the greatest challenge has been, and if you still recommend that like vertically integration as the best way of kind of building a company in this space sector.
That's a great question. It's almost an impossible question to answer. I mean, so with respect to vertical integration, that's easy to answer because the reality is that everything in space is at subscale. So whenever you want to do anything at scale, it's just impossible. I mean, I remember when we were looking for some like cryogenic valves, and we called up a cryogenic valve company, and it's like, yep, we want some of these valves, and they're like, yeah, that'll be 9 months. It's like 9 months. Who's got 9 months? I mean, the entire Electron program, we started in 2014 and 2017, it was on the pad. He's got 9 months to wait for a valve. So, the reason why it's 9 months is because, you know, they only build like 3 a year. So, you know, everything's at subscale. So vertically integrating is the only way you can move quickly, have really good, you know, reliability and of supply chain. Now, the downside to being vertically integrated is it's all about scale, because you have to amortize everything over, you know, all of that infrastructure that you've built. So for us, we're incredibly sensitive to launch numbers and to scale. With respect to the hardest thing, I mean, there's not kind of one thing that is kind of super hard. I think if you wrote down everything that you have to do on a piece of paper, you would just walk away, because it's just like you wake up every morning, you do battle with physics, you do battle with regulation, and then you're trying to build a company. Like if we were making cookies, like scaling at the rate that we've scaled would be hard. And that's just for cookies. Now let's talk about building space launch vehicles. I mean, it's just, you know, like I say, there's no physics problems in cookies. Well, there could be, not make cookies, but you know what I mean. You're not having to fundamentally push the limits of every material and you know, every system every single day. So there's not kind of like one thing that was the hardest. It's just you know, a continual stream of hard, but that's what makes it fun.
Thanks, Stefano, for the question. I'm going to take one more before we wrap up from Andres Permi.
Hello, Mr. Beck. Thank you again for meeting with us. I'm Andres Permoy. I'm with the Georgetown University Space Initiative. You mentioned earlier that one hurdle Rocket Lab and New Zealand has really faced is a lack of the general public's understanding and education about space, and how there's just a bit of a disadvantage in the sense that they don't have as much in hand with compared to what the US does. So my question is, what has Rocket Lab done, and what does Rocket Lab plan to do to kind of spread awareness and kind of make a lot of what Rocket Lab's doing general knowledge? Is it mainly through public events, or do you think Rocket Lab will maybe make some sort of partnership, kind of like how JPL has this partnership with Caltech?
You know, that's a great question. So, and that kind of tees into the talent question as well. So, I mean, you know, we have the Space Ambassadors program where we go to schools, and you know, we've done, like I said, over 100 schools, visited over 100 schools. We've got 150, in fact. We've got another 50 to do this year. And that's really important. We actually found that it was a complete waste of time going to kind of high schools or secondary schools. By the time, you know, most of those folks who are about to go to university, they're already kind of augured in. And you actually need to make the change well earlier on. So we go to primary schools. Sort of the sweet age is around about, you know, 9 to 12, call it. And I can give you an example. So we went to one school, and it was like a careers day, and you had to dress up what you wanted to be. And all these kids dressed up, and there was always a disproportionate number of firemen, and pretty much most of the other kids dressed up at what their parents did, and then, you know, there was the odd kind of thing like that. And then, you know, we use Rocket Lab and the rocket to teach two things really: is teach teach that STEM is cool, but also teach entrepreneurship, because that's something in New Zealand that just doesn't even exist. So we use that opportunity to teach that. Now, I went back the following year to the same event, and that when I went back the next year, there were 3 kids walking around in white lab coats with clipboards being scientists. And out of those 3 kids, 2 were girls. So that was pretty cool, and it actually works if you can get in early into those younger schools and really really show what can be achieved in a career in STEM. We run a PhD program in collaboration with Canterbury University, so we've had 4 PhDs through there. We also work with Auckland University. We flew the very first New Zealand academic satellite built by the Auckland University team. Rocket Lab actually funds a spin-out startup company out of Auckland University. We're an investor in that. Down in the community, we run scholarships for underprivileged kids. We put 3D printers in schools down there, and we do whatever we can with sponsoring certain things, especially around the launch site, because that is a community that that is kind of disadvantaged in some ways, being so remote. So we certainly do a lot, but at the end of the day, we can't compete with a rugby match. We'll announce we're going to the moon, but the leading story is always an All Black who bought a new car or something like that. That is just the psyche of the nation, and it's going to take a while before space ever becomes on par with the All Blacks. But we'll take that as we'll try and achieve that as a goal.
Okay, I'm really sorry to everyone else who had questions that we're not going to be able to fit those in. By the sounds of it, Pete, because we're already in university, it's too late for us. But I do think that the speech you've given us today and honestly being candidly answering our questions does make an impact to all of us. And we really, really appreciate you taking the time to speak to us here today. Thanks for sharing your story. Thanks for being an inspiration. And I hope we'll be able to see you, in person in the springs, if not this year, but in the future.
Certainly hope so. Thanks very much, guys. Lovely to talk to everybody, and thanks for the opportunity to speak at the forum.
Thank you very much, and I hope you have a good Sunday.
Cheers. Thanks.
See ya. Everyone else, we're just going to take a very quick 1-minute break as we switch over our YouTube streams, and then Kristen is going to be back to introduce the next speaker. So please don't go anywhere. We'll be just a minute.